Hello everyone, Dennis here. In this video, I'm going to discuss with you GCE O-Level Physics October-November 2021 paper 1. The subject code is 6091. Alright, now let's start discussing the paper. We start with question 1. A boat crosses a river and arrives at a point due north of its starting point. The boat has a speed of v in still water. A wind is blowing from west to east, causing the boat to move with a speed of w in the same direction. Which diagram represents the resultant velocity r of the boat? So here are the diagrams. The answer for this question will be C. Alright, now why C is the answer? Let's study the question. The first sentence, it tells us that the boat arrives at a point due north of its starting point. Okay, so in the diagram C, this is the starting point and this is the ending point. So the ending point must be due north of the starting point. The next sentence, a wind is blowing from west to east, causing the boat to move with a speed of w in the same direction. Okay, hence, for this vector, it has to point from west to east and label as w. Okay, and the next information, the resultant velocity. So resultant vector connects the starting and the ending points. Hence, the r is the resultant velocity, and in diagram C, it connects the starting point and the ending point. Hence, the answer is C. Question 2. A car travels with uniform acceleration along a straight road. There are posts every 120 meters at the side of the road. When the car passes one post, it has a speed of 14 meters per second. When the car passes the next post, its speed is 26 meters per second. The average speed of the car between the posts is 20 meters per second. What is the acceleration of the car? A. 1.4 meters per second square. B. 2.0 meters per second square. C. 2.6 meters per second square. Or D. 3.3 meters per second square. Okay, to answer this question, we need to calculate the acceleration. So given that this is a uniform acceleration, hence we can apply this formula, v squared equals u squared plus 2as. Remember, we only can use this formula when the acceleration is uniform. Then we substitute the values given, where v, which is the final speed, is 26 meters per second, u, which is the initial speed, given 14 meters per second, and the s is the distance traveled, which is 120 meters. Then we solve this equation, we get a equals 26 square minus 14 square divided by 2 times 120. Hence, a is 2 meters per second square. Therefore, the answer is B. Or you can use another method, because you might wonder why they give us the average speed. So average speed is 20 meters per second. So we can use the average speed formula, which is the total distance divided by the total time traveled. So let's label as t. Then we substitute the value. average speed is 20, the distance is 120, hence t will be 6 seconds. Then we can calculate the acceleration, which is a equals v minus u over t. The v will be 26 meters per second and the u is 14 meters per second, then divided by 6 seconds, we get the acceleration is 2 meters per second square. You can use either of these two methods, but both of the methods give you the same answer. So the answer will be B, 2.0 meters per second square. Question 3. What is a complete description of non-uniform acceleration? A. A rate of change of speed that is constant with time. B. A rate of change of speed that varies with time. C. A rate of change of velocity that is constant with time. And D. A rate of change of velocity that varies with time. Okay, so this question you need to define what is the meaning of non-uniform acceleration. Okay, so actually there are two things that you need to understand. First, the non-uniform acceleration, and second, you need to know what type of quantity is the acceleration. Okay, so is it a scalar quantity or a vector quantity? Okay, so now let's talk about the first one first, the non-uniform acceleration. So the non-uniform acceleration, which means it is a rate of change that varies with time. Okay, so if constant with time, it will be out. And second, is it about the rate of change of speed or the rate of change of velocity? Okay, so speed is a scalar quantity and velocity is a vector quantity. Okay, as I mentioned just now, right? Acceleration is a vector quantity. Hence, the definition for non-uniform acceleration should be D. It is a rate of change of velocity, which is a vector quantity, and varies with the time. Next, let's move to question 4. A book rests on a table. The earth exerts a force F on the book. Which force with F makes an action-reaction pair? A. The force of the book on the earth. B. The force of the book on the table. C. The force of the earth on the table. Or D. The force of the table on the book. Okay, so this question may be a bit confusing because it involves three objects, which is the table, the earth, and the book. Okay, and you need to decide which force from where to where. Okay, so to answer this question, we need to relate it to Newton's third law because it is related to the action-reaction pair, which is explained in Newton's third law. Based on Newton's third law, when an object A apply a force to object B, then object B will react back with the same amount of force but in the opposite direction to the object A. Okay, so for this case, object A will be the earth and object B will be the book. Hence, the book will react back with the same amount of force in the opposite direction towards earth. Hence, the answer is A, the force of the book on the earth. Question 5. A child rides down a slide. So, these are the 4 possible free body diagrams for this child riding down the slide. Which free body diagram shows the directions of the forces acting on him? Okay, so you need to decide. There are 3 forces in this body diagram: the contact force, friction, and the weight. So where should these 3 forces point towards? Okay, so the answer will be A. Okay, the reason, let's study the force one by one. We start with the contact force. This contact force, it must be perpendicular to the contact surface. So the contact surface is slanted like this, which is the slides. So this contact force need to be perpendicular with this contact surface. Hence, it is pointing in this direction. Next, the weight. So the weight always acts downwards with the direction of the gravitational field, G, which points towards the center of the Earth. Okay, so it doesn't matter how the contact surface look like, right? Whether inclined like this or a flat surface, this weight will always point towards the center of the Earth, hence it's pointing downwards. Next one, talk about friction. So friction opposes the direction of motion. Okay, so in this free body diagram, since this child is moving downwards, hence this will be the direction of motion, and friction will always opposes the direction of motion. So the answer will be A. Question 6. A force of 18 Newton is applied to an object at rest. A frictional force of 6.0 newtons acts on the object when it is moving. The speed of the object increases to 6.0 meters per second in 2.0 seconds. What is the mass of the object? A. 2.0 kilograms, B. 4.0 kilograms, C. 6.0 kilograms, or D. 8.0 kilograms. Okay, so to answer this question, we need to do some calculation. We start with a free body diagram. So this is an object at rest. So a force of 18 newtons is applied on this object. So we can draw on this body diagram an arrow pointing to the right, which represents the driving force equivalent to 18 newtons. So this object is at rest, which means the initial speed is 0 meters per second. Next, frictional force is 6.0 newtons. So we need to draw this on the body diagram. So remember, the frictional force is always opposes the driving force. Hence, it will point to the left, and the frictional force is 6.0 newtons. Okay, now next sentence, it says the speed increases to 6.0 meters per second in 2.0 seconds. So, which means now the final speed v will be 6.0 meters per second after time 2.0 seconds. So based on this information, we can calculate the acceleration A equals v minus u over t. Then you substitute the values, which we have 6.0 minus 0 divided by 2 seconds, and the acceleration is 3.0 meters per second squared. Okay, now the next thing we need to do is we form this formula. The resultant force F is equal to the driving force minus the frictional force, and resultant force F also equals to MA. Hence, the equation becomes MA equals 18 minus 6. Okay, because driving force is 18 newtons and frictional force is 6 newtons. Also, the acceleration is 3. Hence, the mass will be 4 kilograms. So the answer will be B, 4.0 kilograms. Question 7. The front wheel of a car is turned in a clockwise direction by the engine as the car accelerates to the right, as shown. There is a frictional force between the wheel and the road. What are the directions of the frictional forces on the front wheel of the car and on the road? So here are a few options to choose. You need to decide whether the direction of frictional force on the wheel is to the left or to the right. Same thing for the direction of frictional force on the road, is it to the left or to the right? Okay, to answer this question, now let's look at this diagram. So the wheel is turning clockwise direction over here, so which means this will be the force applied by the wheel on the road. Okay, so this force applied by the wheel to the road will be the frictional force on the road. Okay, remember the car needs to move to the front, hence in this direction, hence this will be the frictional force applied by the road by the wheel to the road. Okay, so that the car can move forward. So A to the left is correct, and C also to the left is correct, but not B and D. Next, we talk about the direction of frictional force on the wheel. Okay, so it will always in the opposite direction with this force. Okay, so this is the frictional force applied by the road to the wheel. Okay, so from the option here, C and D are correct for the direction of the frictional force on the wheel, but not A and B. Hence, from here, option C, both of the direction here are correct. Hence, the answer is C. Question 8. A spacecraft is sent to the surface of Mars. The gravitational field strength on the surface of Mars is 3.8 newtons per kilograms. The gravitational field strength on the surface of the Earth is 10 newtons per kilograms. How does the mass and the weight of the spacecraft on Mars compare with the mass and the weight of the spacecraft on the Earth? So here are a few options. So you need to tell how the mass on the Mars change compared with the Earth. Similarly, the weight on Mars compared to the weight on the Earth. Okay, to answer this question, we talk about the mass first. So we need to recall the definition of mass, which is a measure of the amount of substance or matter on an object. Okay, which means the mass is always constant regardless the location of the object. Okay, hence A will be incorrect because the mass has changed less on Earth, less than on Earth. Okay, now next one, we want to decide the weight. Okay, the weight definition will be W equals to mg, where weight is directly proportional to the gravitational field strength G. Okay, so it heavily depends on the location of the object, whether it is on Mars or on the Earth. Okay, so we see that the gravitational field strength on the surface of the Mars is 3.8 newtons per kg, which is less than the gravitational field strength on the surface of the Earth, which is 10 newtons per kilograms. Okay, which means G on Mars is less than G on Earth. Therefore, the weight on Mars will be less than the weight on Earth. Okay, hence option C is correct. Therefore, C is the answer. Question 9. A uniform rod of weight 12 newtons is hinged at one end. So let's draw a diagram to illustrate the description here. So this is the uniform rod with the weight of 12 newtons. It is kept horizontal by applying a force F as shown. So one force is applied at this end, and it is hinged at this point. So this we extend the line here, and this is 80 centimeters perpendicular with another line towards the hinge, and this length is 60 centimeters. This distance is 50 centimeters. What is the size of force F? A 6.0 newtons, B 7.5 newtons, C 10 newtons, or D 12 newtons. Okay, to answer the question, we need to determine the size of the force. So first, we need to relate it to the concept of moment, where moment is the product of the force F and the perpendicular distance d from the pivot to the line of action of the force. Okay, so based on this definition, then we can calculate moment with this formula: m equals to F force multiplied with the perpendicular distance d. And we need to relate it to the principle of moment, which states that for an object to be in equilibrium, the sum of anticlockwise moments equals the sum of clockwise moments. Hence, we can have this equation: sum of clockwise moment equals sum of anticlockwise moment. Okay, so now we need to determine where is the clockwise moment and where is the anticlockwise moment from this diagram. Okay, so to determine that, we need to identify where is the pivot. So the hinge here is the pivot. And since this is the pivot, so this force, when applied in this position, it will create the clockwise direction of moment. And next, we need to find the length of the rod, which label is L. So the length of the rod, we can apply Pythagoras theorem because this is a right angle triangle. So the L will be the hypotenuse of this right angle triangle. Hence, is L equals square root of 60 square plus 80 square, which get us L equals to 100 centimeters. Okay, which means we label this as D1. The D1 will be 100 minus 50 because this distance is 50 centimeters. The whole length of the rod is 100 centimeters. So D1 will be 50 centimeters. Hence, the clockwise moment will be this 12 newtons minus multiplied with D1, which is 50, and equals to, we need to identify the anticlockwise moment, which is from this force. When I apply this force at this point, it will create a anticlockwise moment. So now the moment will be the force multiplied with the perpendicular distance, which is 60 centimeters. So the perpendicular distance from the force to the pivot. Okay, so the calculation here becomes F times 60. Then you solve this equation, F equals 12 times 50 divided by 60, which is 10 newtons. So the answer will be C, 10 newtons. Question 10. What is meant by center of gravity? A. A point in a body through which all forces pass. B. A point where all forces acting on a body are equal. C. A point where the mass of a body is concentrated. Or D. A point where the weight of a body is considered to act. Okay, to answer this question, we need to recall the definition of center of gravity, which describe it as a point from which the weight of a body or system seems to act on it. Okay, so based on this definition, then the answer will be D, a point where the weight of a body is considered to act. Question 11. The diagram shows the shape of a solid object with its center of gravity marked. Okay, as you can see, the center of gravity is at the higher end of this object. Which action makes the object more stable? A. Add an extra weight on its top surface. B. Make the object from a less dense material. C. Move it to a place where the gravitational field is larger. Or D. Turn it through 180 degrees so that its top surface is now resting on the bench. Okay, so to answer this question, we need to understand that the stability of an object can be increased by two ways. Number one, we increase the base area. So either we increase the base area here, or number two, we lower the center of gravity. Okay, so for this case, which one is easier? Of course, we turn this object through 180 degrees so that the top surface now is resting on the bench. Okay, so what's the reason? When it is stable, the center of gravity will be as close as possible towards the earth. Then it will be stable. Hence, for this case, the answer will be D. Question 12. A cylindrical tube of uniform cross-sectional area 0.25 centimeters square contains a liquid. The depth of the liquid in the tube is 120 centimeters and the density of the liquid is 0.80 grams per centimeters cube. The gravitational field strength G is 10 newtons per kg. What is the pressure due to the liquid on the base of the tube? A. 0.096 newtons per centimeter square. B. 0.96 newtons per centimeter square. C. 96 newtons per centimeter square. Or D. 960 newtons per centimeter square. Okay, so to answer this question, we need to calculate the pressure of liquid, which the formula is P equals rho GH. Okay, but before I want to calculate the pressure, we need to check the unit first. Okay, so this question is a bit tricky. So first we check the length. Okay, length, area, and the volume all are in centimeters, centimeter square, and centimeters cube. Alright, but now the density is in grams per centimeters cube, but the gravitational field strength is in newtons per kg. Alright, so we need to be careful over here. The unit is not the same for the mass. Okay, one is gram, one is kg. So, and the answer will be is in newtons per centimeters square. Alright, so first we don't have to convert the centimeter square, okay, to standardize because they're already in the standard or the same units. The second thing is we also don't have to convert them into meters or meters, meter square or meters cube because the answers is in centimeters square. Okay, so now let's change the density here, right, from gram centimeters cube to kilogram centimeters cube. Okay, so this gram centimeters cube, I can write in this manner. The rho equals to 0.80 grams over centimeters cube. And I want to convert to kg for this. So what I need to do is we times with 1000 over 1000. And I rewrite here, right, is 0.80 divided by 1000 and 1000 grams over centimeters cube. So why I want to write in this manner? Because I want it in kilograms per centimeters cube. And over here is 0.80 divided by 1000, which becomes 0.0008 kilograms per centimeters cube. Okay, now we can substitute this value inside the formula of the pressure here. Rho is 0.0008. The G will be 10, and the height will be 120 centimeters, which come from here. Okay, then we can calculate the pressure, which is 0.96 newtons per centimeters square. Hence, the answer is B. Question 13. A force F is applied to the smaller piston of a hydraulic press as shown. Which outward force acts on the larger piston? A. F over 4. B. F over 2. C. 2F. Or D. 4F. Okay, so to answer this question, we need to calculate the outward force acts on the larger piston. Okay, now let's label this F, right, which is the force applied on the smaller piston. So it is pointing downwards. We label this force as F1. Okay, and the outwards force acts on the larger piston. We label this force as F2. So this will be the area for the smaller piston. this will be the area for the larger piston. So we label them A1 and A2 respectively. Okay, so now these two pistons are at the same level. So which means the pressure under each piston will be the same. So let's label the pressure under the piston, the smaller piston is P1 and the pressure under the larger piston as P2. So since they are at the same level, then P1 equals to P2. So the pressure will be the same. Okay, and based on the formula of pressure F over A, so this formula or this equation becomes F1 over A1 equals to F2 over A2. So rearrange this equation, we have F1 over A1 times A2 equals to F2. Then we substitute the information given. So we make F2 the subject. So F2 equals to F1 over pi times 10 square, then times pi 20 square. So we cancel out the pi, and we calculate the F2 as 20 square over 10 square times F1, which is 4F1. So remember, the F1 is the F as shown on the original diagram. Hence, the F2 equals to 4F. Answer is D. Question 14. A fish in the ocean releases a bubble of gas. The bubble rises to the surface as shown. Okay, so look at this diagram. This fish releases a bubble, and this bubble will rise to the top of the surface here, and this will be the depth D. Okay, which diagram shows how the pressure P of the gas in the bubble varies with its depth D below the surface of the ocean? So here are the four diagrams: diagram A, diagram B, diagram C, and diagram D. Okay, so to answer the question, okay, we need to label the diagram first. So this, at this point, this is the pressure experienced by the bubble of gas. Okay, so which is the P here. And from this diagram, the P is equals to first atmospheric pressure P atm, and also the pressure of the water P water. Okay, so plus P water. And we know that P water, the pressure of liquid is rho GH, and H equals to D. Okay, we have to base on the diagram here. So the height of the liquid is the D here. Hence, we update the equation, which is P equals to P atm plus rho GD. So from here, we can see that the atmospheric pressure P, the rho, density, and the G, the gravitational pull force, all of them are constant. Okay, so now from this equation, you see that they are in the form of y equals to c plus mx, or y equals to mx plus c, which means this is a linear equation. So from these four options, C will be the correct answer because it is the graph of a linear equation. Question 15. Given this diagram, box 1 and box 2 are identical. Box 1 is lifted vertically. Box 2 is lifted through the same vertical height along a rough incline as shown. Which statement is correct? A. Both boxes gain equal quantities of gravitational potential energy as they are lifted through the same height. B. Both boxes gain equal quantities of gravitational potential energy as the forces do the same amount of work. C. Box 2 gains more gravitational potential energy as the force does more work. Or D. Box 2 gains more gravitational potential energy as it moves further. Okay, so over here, there are two things that you need to answer. First, whether both boxes gain the same amount equal quantities of gravitational potential energy, or one of them has more gravitational potential energy. And the second thing that you need to decide is whether either one of the boxes does more work or both of them do the same amount of work. Alright, so let's go to the first part first, where we need to know whether which boxes have more gravitational potential energy or they are the same. So based on the formula of gravitational potential energy, mgh, the m is the mass of the object, g is the gravitational field strength, and the h is the vertical height of the object. Okay, so since both boxes, right, are identical, which means we can assume that they have the same amount of mass. Okay, and the g of course is a constant. Okay, it happens on Earth, then it's 10. Alright, and the vertical height, so this will be the vertical height for both boxes. Alright, in other words, both of the boxes will gain equal quantities of gravitational potential energy. Okay, so in other words, actually C and D are out because they say that the box 2 gains more gravitational potential energy. Okay, now we answer the second question. How about the work done? Are they the same, or one of the boxes does more work? Okay, we need to go to the formula for work done, which is F times S, where F is the force acting on the object and the S is the distance traveled in the same direction of the force. Okay, so which means this S, based on this diagram, this will be the S done by the force here. And for box 1, this H is also the distance S here for the work done. Okay, as you can see from here, right, they have the same force, but the S is different. Okay, so this S is longer than the height. In other words, box 2 does more work than box 1. Okay, so now from just now we already eliminate C and D. For B, it mentions that both boxes do the same amount of work, so which is not true. Hence the answer is A. Both boxes gain equal quantities of gravitational potential energy as they are lifted through the same height. Question 16. A lorry is traveling at a constant speed of 90 km per hour along an expressway. The forward force on the lorry is 3,600 newtons. What is the work done in each second by this force? A. 5,400 joules, B. 40,000 joules, C. 19,000 joules, or D. 324,000 joules. Okay, so to answer this question, we need to do the calculation. So the question is asking the work done in each second. So given that the speed of the lorry is 90 kilometers per hour, so which means 1 hour it travels 90 kilometers. 1 hour will be 60 times 60, which is 3,600 seconds, and 90 kilometers means it's 90,000 meters. Hence, 1 second it will travel 90,000 divided by 3,600 meters, which we get 25 meters. Alright, which in other words, the speed is 25 meters per second. Now I want to find the work done for every second, so it will be F times S, where the force given is 3,600 newtons, which is here, and the S is 25 meters. So we calculate, we get 90,000 joules. Hence the answer is C. Question 17. When smoke particles are viewed under a microscope, they can be seen moving with Brownian motion. Which row describes and explains Brownian motion? Here are 4 options. Okay, so to answer this question, you need to know whether the motion is random or vibration, and in the explanation part, you need to explain whether the smoke particle bombard the air molecules or the air molecules bombard the smoke particles. Okay, so now let's see this animation where we can observe through the microscope. So this is a smoke particle, and when you observe through the microscope, this is what we observe. Okay, as you can see, the smoke particle moves at zigzag manner and random, hence it does not vibrate, and option C and option D are eliminated. Now secondly, to explain whether the smoke particles bombard the air molecules or the air molecules bombard the smoke particles, let's see this animation again. So this is the air molecule which we can see through the microscope. Okay, now when the smoke particles move to this direction, the air molecules collide with the smoke particle, and they change direction and collide with another air molecules. After that, it will change direction again. Therefore, it is the air molecules that bombard the smoke particles and make it to change direction, not the smoke particles bombard the air molecules. Therefore, the answer is B. Question 18. The cooling unit of an air conditioner is placed near the top of a room. The air conditioner takes in warm air and gives out cold air, which sinks. Which statement explains this? A. A cool air molecule is denser than a warm air molecule. B. A cool air molecule is less dense than a warm air molecule. C. The cool air is denser than the warm air. Or D. The cool air is less dense than the warm air. Okay, so this question will be tricky. Okay, why? Because if you don't read this question carefully, you might tend to choose question. The answer is A. Alright, now we know that warm air will rise because it has less density, while cool air will sink because its density is higher. Okay, so now you need to relate it to density, which the formula for density is rho equals to the mass over the volume, which means the amount of substance per 1 unit of volume. Okay, now look at these two containers, container A and container B. As you can see, in container A, it has less molecule inside 1 unit of the volume compared to container B. It has more molecules per unit volume. Hence, I would say the container A has lower density while container B has higher density. Okay, so from here, it is about the number of molecules per unit volume, which is density. Okay, but for option A and option B, they only mention one particular air molecule. Okay, whether it's cool air molecule denser than the warm air molecule. Okay, whether it is cool air molecule or warm air molecules, they should have the same density. So the answer for this question will be C. The cool air is denser than the warm air. Question 19. A fixed mass of gas expands at constant temperature. What happens to the pressure of gas and to the average speed of the gas molecules? So you have 4 options here, A, B, C, D. So what you have to do is you need to answer whether the pressure of gas decreases or increases, and the average speed of gas molecules, whether it decreases or remain the same. Okay, so to answer this question, let's look at the information given. So the gas expands at constant temperature. which means the distance between molecules increases. Okay, when the distance between molecules increases, the pressure of gas decreases. Alright, now next one, at constant temperature, when the temperature is constant, it means it is constant kinetic energy. So we know that kinetic energy formula is half mv squared. So the m mass is a constant. Then since kinetic energy constant, the average speed of gas molecules will remain the same. Therefore, the answer is B. Question 20. A liquid changes state by boiling. Which statement about this change of state is correct? A. Thermal energy is not supplied and the temperature decreases. B. Thermal energy is not supplied and the temperature is constant. C. Thermal energy is supplied and the temperature increases. D. Thermal energy is supplied and the temperature is constant. Okay, so to answer this question, you have to answer two questions, which is whether the thermal energy is supplied or not supplied, and second thing, how about the temperature? Does the temperature decrease, constant, or increase? Okay, so now look at the situation here. This liquid is changing state by boiling. Alright, so boiling only happens when the temperature reaches the boiling point. Okay, when it is at boiling point, that means the temperature is constant. Okay, so that means option A and option C are wrong. So left with option B and D. Now, the next question is whether the thermal energy is supplied or not supplied. Then of course, we have to continue to supply the thermal energy. Alright, so that the temperature will remain. Okay, when we supply thermal energy, we are increasing the potential energy of the liquid when it is changing the state. Question 21. The diagram shows a liquid in glass thermometer which can read temperature from -10 degrees Celsius to 110 degrees Celsius. What is the difference in temperature between the two fixed points? A. 10 degrees Celsius, B. 100 degrees Celsius, C. 110 degrees Celsius, or D. 120 degrees Celsius. So this question wants us to find the difference of the temperature. So the difference is the larger value minus the small value. So for this case, the range is from -10 degrees Celsius to 110 degrees Celsius. Hence, difference will be 110 minus -10, which gives us 120 degrees Celsius. Therefore, the answer is D, 120 degrees Celsius. Question 22. Steam at 100 degrees Celsius from a kettle condenses on a mirror. What happens to the kinetic energy and to the potential energy of the molecules during the process of condensation? So here are a few choices. What you have to do is you need to identify whether the kinetic energy decreases or stays the same, and potential energy whether it decreases or stay the same. Okay, so for this case, the steam is at 100 degrees Celsius and condenses on a mirror. So the process will be the gas to liquid, which means it changes the states. So when the matter change states, the potential energy decreases. When the potential energy decreases, kinetic energy will remain constant. Hence, the answer will be C. Kinetic energy stays the same while potential energy decreases. Question 23. The mass of a metal pen is 2.0 kilograms. The pen absorbs 3,800 joules of thermal energy or heat, and this produces a temperature rise of 5.0 degrees Celsius. what is specific heat capacity of the metal and what is the heat capacity of the pen. So here are the choices A, B, C, D. So to answer this question, we need to calculate both the specific heat capacity and heat capacity with their own formulas. So this is the formula for specific heat capacity. C equals to Q over M delta theta, where Q is the energy absorbed, M is the mass, delta theta is the temperature change. So we substitute the values given, where Q is 3800 joules, mass is 2.0 kilograms, and the change of the temperature is 5.0 degrees Celsius. Then we calculate the value, we get 380 joules per kg per degree Celsius. Alright, on the other hand, this is the formula for heat capacity, which is capital C equals Q over delta theta, where Q is the energy absorbed, delta theta is the change in temperature. So substitute the value, Q is 3800 joules divided by the change of temperature, which is 5.0 degrees Celsius, and the value is 760 joules per degree Celsius. Therefore, the answer is B. Specific heat capacity is 380 joules per kg per degree Celsius, and heat capacity is 760 joules per degree Celsius. Question 24. In order to determine how well materials conduct heat, an intense flash of light is directed at the surface of some samples. Immediately afterwards, the temperature T of the other surface of each sample is measured. So this diagram illustrates this experiment. The samples are blocks with identical dimensions and the same initial temperature. In which block is T the smallest? A. Block with a large heat capacity made from a good thermal conductor. B. Block with large heat capacity made from a poor thermal conductor. C. Block with a small heat capacity made from a good thermal conductor. And D. Block with a small heat capacity made from a poor thermal conductor. Okay, so to answer this question, you need to decide two things. The first thing is whether the block has a large heat capacity or small heat capacity. And second, whether this block is a good thermal conductor or a poor thermal conductor. Okay, the first thing you need to know is if a block has large heat capacity, then it should be a poor thermal conductor. On the other hand, when it has a small heat capacity, then it should be a good thermal conductor. Okay, think about it. If you have small heat capacity, that means you just need to supply small amount of heat, then the temperature will increase. On the other hand, if you have large heat capacity, then you need to have a lot of energy supplied so that the temperature will increase. Okay, so for this case, when you have a large heat capacity, then you are a poor thermal conductor. Okay, if you have a small heat capacity, then you are a good thermal conductor. Therefore, from here we can eliminate option A, where it has large heat capacity but a good thermal conductor, and also option D, small heat capacity and a poor thermal conductor. Alright, so the possible answer could be either B and C. Now, we need to determine whether this block is a poor or good thermal conductor. So, if you want the temperature at this end to be smallest, that means we need to have as least thermal energy as possible to be conducted through this block. Okay, in other words, we need this block to be a poor thermal conductor. Therefore, the answer will be B. Question 25. A ray of light passes from air to glass, as shown in this diagram. Which quantity gives a constant value as the angle of incidence of the ray changes? A. Sin P over sin R. B. Sin Q over sin S. C. sine P over sine S, or D, sine Q over sine R? Okay, to answer this question, we need to understand what does it mean by this constant value. So this constant value is the refractive index with the formula n equals to sine I over sine R, where I is the angle of incidence and R is the angle of refraction. So from this picture, this angle P is the incident angle. Incident angle is measured from the normal to the incidence ray. Okay, now next one, this angle is the refracted angle. Okay, remember, refracted angle measured from the normal towards the refracted ray. Okay, so answer will be sine P over sine R. Okay, because P is the incident angle with this formula, R will be the refracted angle, hence is sine P over sine R. Question 26. A person at the back of a crowd uses a periscope to look over the heads of people in front of the stage. As shown in this diagram, this is a periscope. The top section of the periscope uses a mirror to change the direction of the light from the stage. The bottom section contains a right-angled prism. The prism is positioned so that it changes the direction of the ray by total internal reflection. How is the prism positioned? Is it A, B, C, or D? Okay, so the answer will be this. So this is how the right angle prism should be positioned. Okay, why? Because when the ray passes through into the prism at 90 degrees, so this ray will not be refracted. Okay, when you come to this surface, so this will be the normal at this point, and this ray will experience a total internal reflection. So it will bend towards this direction. Alright, so when you come to this surface, again, this is a 90 degrees, right? Then the ray will not be refracted, it will just continue to go straight. Hence, the answer will be A. Question 27. Which statement about microwaves is correct? A. They have a higher frequency than visible light and cannot cause heating of body tissue. B. They have a lower frequency than visible light and cannot cause heating of body tissue. C. They have a higher frequency than visible light and can cause heating of body tissue. D. They have a lower frequency than visible light and can cause heating of body tissue. So, to answer this question, you need to determine two things. The first is whether microwaves has higher or lower frequency than visible light. And the second thing is you need to determine whether microwaves can cause heating of body tissue or cannot cause heating of body tissue. Okay, so to determine whether the frequency is higher or lower than visible light, we need to refer to the electromagnetic spectrum. Let's recall this electromagnetic spectrum. We start with radio wave, followed by microwave, infrared, visible light, where in visible light, there are 7 colors, which start with red, orange, yellow, green, blue, indigo, and violet. After visible light, the next ray is ultraviolet, followed by X-ray, and the last waveform is gamma ray. So from this electromagnetic spectrum, the waves at the beginning has lower frequency, and as we move down, the waves at the end has high frequency. So microwave is at this location, it is above the visible light, hence it has lower frequency than visible light. So for option A, it mentions that microwaves has higher frequency than visible light, so this is eliminated. Similarly, for option C, it also mentioned higher frequency, hence this is eliminated. Okay, now the next part we will have to determine whether microwaves can or cannot cause heating of body tissue. So remember that microwaves are used in microwave oven where we use it to heat food. Therefore, microwaves can cause heating of body tissue. Then the answer will be option D. Question 28. Ultrasound is used to detect a crack in a piece of metal, as shown in this diagram. The scanner emits a pulse of ultrasound which is reflected from the crack. The reflected pulse is detected by the scanner. The question is, which quantity does the scanner measure to determine the position of the crack? Option A, the wavelength of the reflected pulse. B, the frequency of the reflected pulse. C, the speed of the reflected pulse. Or D, the time between emission of the pulse and detection of the reflected pulse. Okay, so to get the answer for this question, we need to use this formula. V equals to distance divided by the time. So the distance is the distance traveled by the emitted pulse and then go back to the scanner. So as shown here, so this is the first D, and when it reflects back, we assume that the distance is the same as when the emitted pulse go towards the crack. Therefore, the total distance will be 2D, and the formula becomes V equals to 2D over T. Then we make D the subject, then it is equals to Vt over 2. So from this equation, we can see that the speed V is constant for sound wave. Therefore, we can measure the time so that we know the distance. Therefore, the answer is D, the time between emission of the pulse and detection of the reflected pulse. Question 29. What always experiences a force when placed in an electric field? A, a coil of wire. B, a magnet. C, a piece of plastic. Or D, an electric charge. Okay, so to answer this question, we need to know that like charges repel and unlike charges attract. So because of this, then an electric charge will experience a force when placed in an electric field. Next question, question 30. A positively charged rod is held close to an earthed metal sphere as shown in this diagram. What describes the charge on the metal sphere? A, it is negative because electrons are attracted towards the rod. B, it is negative because protons are repelled by the rod. C, it is neutral because electrons are attracted towards the rod and protons are repelled. Or D, it is neutral because it is earthed. So the answer for this question will be A. It is negative because electrons are attracted towards the rod. So here is the animation. When a positive charged rod is placed to the sphere, electrons are flown from the earth, attracted towards the positive charge on the rods. Hence, the answer is A. It is negative because electrons are attracted towards the rod. Question 31. Electrostatic charging is used to photocopy a document. The image of the document is projected onto a positively charged copying plate. The following steps are the remaining parts of the process. Step P. Negatively charged black toner particles are attracted to the remaining positive area. Step Q. Paper is placed over the copying plate and toner is transferred to the paper and heated so that it sticks. Step R. Where light falls on the plate, the electrical charge leaks away. Which is the correct order of these steps? A. P R Q, B. Q P R, C. R P Q, or D. R Q P. Okay, so to get the answer for this question, we need to understand how photocopying process works. So we start with this document with image, and at the bottom here, this is positively charged plate. So lights will be shown onto the document. When the light hits the black surface, it will be absorbed. When it hits the white surface, it will be reflected. So the reflected lights will hit the positively charged plates, then neutralize the charges on the plate. So the area that is not contacted with the reflected light will remain charged, while the area that is hit by the light will be neutralized. Hence, a positively charged image is formed on the plate. Then we will spray toners on the plates so that we can place a piece of white paper on top of this plate. Then we heat it up so that the toner will stick onto the paper. And finally, we will form a photocopied document. So the order will be C, R, P, and Q. Question 32. An electric screwdriver's battery takes 20 minutes to charge. The current in the battery during charging is 300 milliamps. How much charge flows through the battery while it is charging? Is it A, 6.0 coulomb, B, 360 coulomb, C, 6,000 coulomb, or D, 360,000 coulomb? So to get answer for this question, we need to do calculation. So we use the formula of the current, which is the rate of change of the charge. So it will be I equals to Q over T, and since we want to find the charge, then we make Q the subject, Q equals to IT. So the current given is 300 milliamps, hence it is 300 times 10 to the power of -3, then times the time. We need to convert it into seconds because it's given in minutes. Therefore, it's multiply 20 and multiply another 60. Then the answer will be 360 coulomb. Therefore, B. Next question, question 33. In 3.0 seconds, 2.5 times 10 to the power of 19 electrons pass through a resistor. As the electrons pass, thermal energy is produced in the resistor at a rate of 4.0 watts. The charge on the electron is 1.6 times 10 to the power of -19 coulomb. What is the potential difference PD across the resistor? A, 3.0 volts, B, 4.0 volts, C, 12 volts, or D, 36 volts. Okay, so to get the answer for this question, we need to first calculate the current. So we use this formula again, I equals to Q over T. And to calculate the charge, look at the information given. So one electron has a charge of 1.6 times 10 to the power of -19 coulomb. And for this example, we have 2.5 times 10 to the power of -19 electrons. So the total charge will be, we take this number, multiply by this number. So 1.6 times 10 to the power of -19 times 2.5 times 10 to the power of 19. Then we divide by 3.0. We calculate, we get 4 over 3 ampere. Next, given that the power is 4.0 watts, and we know that the current is 4 over 3 ampere, we want to find the potential difference. Then we use this formula, P equals to VI, and make V the subject because we want to find the potential difference. So equals to the power divided by the current, which is power is 4, then divided by 4 by 3, or 4 times 3 over 4, which is 3 volts. Hence, the answer is A, 3.0 volts. Next question, question 34. The graph shows how the current in a diode varies with the potential difference PD across it. So here is the graph. Which is the order of resistance values of the diode at point J, K, and L? So here are the choices: A, J, K, L, B, J, L, K, C, K, L, J, or D, L, K, J, arranged from the largest resistance to the smallest resistance. Alright, so for this question, the answer is A. The reason is because based on the Ohm's law, V equals to IR, then we know R equals to V over I. So this is how we calculate the resistance. This graph is an IV curve. So an IV curve, to get the resistance R, it will be 1 over gradient. So as you can see, when the gradient is small, then the resistance will be high. When the gradient is high, the resistance will be low. So the resistance is inversely proportional with the gradient. Therefore, the answer is A. Question 35. The diagram shows a circuit containing 5 identical resistors. What is the ratio of the current at L to the current at M? A 2.5, B 3.0, C 4.0, or D 5.0. So, in order to obtain the ratio of the current at L, which is this point, to the current at M, which is this point, we need to calculate the currents at this point and at this point. Okay, so first let's look at the question. So these 5 resistors are identical, which means they have the same resistance. So we need to draw the equivalent circuit for this diagram. So the first branch and the second branch of this circuit, the resistors are connected in series. Hence, we can label this resistor as 2R and this resistance as 2R, and the last one still remain as R. Next, this is how the current flow start from the positive terminal from the battery, flow into point L. We label this as I1. Then continue, we'll come to this node. The current split into 2, and come to this node, we split another 2 here. So let's label the current that flow through point M is I2. And then after that, all this current will join together and flow back to the negative terminal of the battery. Okay, so now look at this diagram. These 3 resistors are connected in parallel. So we can calculate the total resistance with this formula. 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. Then we substitute the values here. The R1 is 2R, R2 is 2R as well, and R3 will be R. Then when we add these together, we will get 4 over 2R, and RT will be equals to R over 2. Now, let's label the voltage at the battery as V. So, the V equals to I1 RT. So the RT will be R over 2. Hence, I1 will be 2V over R. Next, we calculate this branch. Since this branch is parallel with the battery, hence the potential difference at this branch will be the same as V. So based on the Ohm's law, it will be I2 multiplied with R2, where R2 will be 2R here. Then we make I2 the subject, so V over 2R. Then we compare these two currents. So I1 divided by I2, because we want to find the ratio of the current at L, so which is the I1 here, and to the current at M. So M is I2. So the ratio become I1 to I2 equals to 2V over R divided by V over 2R. So we change the division to become multiplication. So this become reciprocal. So cancel out the R, cancel out the V, and we find it is 4. Hence, the answer is C, 4.0. Question 36. In which circuit in these 4 diagrams is the potential difference PD between point P and point Q greater than 0? So the keyword here is greater than 0, which means VP minus VQ should be greater than 0, or VP is greater than VQ. Alright, so to obtain VP and VQ, we need to calculate them separately using the potential divider formula, which means here is the circuit where this is the VI, this is R1, this is R2, and we tap the voltage here, V2, at this point. So V2 equals R2 over R1 plus R2 times V1. So this is the potential divider formula. We need to calculate VP and VQ for each diagram here one by one and see if VP is greater than VQ. So the first option A, VP equals to VQ, which is 5 over 15 times 6, and the value is 2 volts. So since VP minus VQ is 0, then this is not the right answer. So for B, VP also equals to VQ, and it is 10 over 15 times 6. We get 4 volts. Since VP equals to VQ, then the difference will be 0, and this is not the correct answer. Now move on to C. We calculate VP, then equals to 10 over 20 times 6, which gives us 3 volts, while VQ equals 5 over 10 times 6, which will give us again 3 volts. From here, VP equals to VQ, or the difference will still get a 0, hence this is not the correct answer. Alright, now we go to the last circuit. VP equals to 10 over 15 times 6, which gives us 4 volts, while VQ equals 5 over 15 times 6, which gives us 2 volts. So the difference here, VP minus VQ equals 2 volts. Hence, the answer will be D. Question 37. A heater has a switch and is connected to a fused mains plug. In which circuit are the switch and fuse connected correctly? So here are the 4 options. So this basically you have to determine where we should connect the fuse and the circuit, whether they need to be connected to live wire or neutral wire. Alright, so the answer for this question is C. Here is the reason. First, for fuse, fuse is connected to live wire to prevent excessive current to flow into the electrical appliance and damage it. So that's why fuse need to connect to the live wire. So when excess current flow through the fuse, and if the current exceeds the rating, then the fuse will melt down and break the circuit. Next, for switch, so switch is connected to live wire for safety purpose. Why? Because when someone opens the switch or disconnects the circuit for repair work, he will get electric shock if the switch is not connected at the live wire. It is connected into neutral wire. Hence, the answer will be C. Question 38. Given this diagram, 3 bar magnets are arranged as shown. 3 magnetic field between the magnets is shown. What are the poles at X, Y, and Z? So here are the 4 options. So to determine the polarity at the ends of X, Y, and Z, we need to understand how the poles work. So we know that like poles repel, unlike poles attract. So the north pole point outwards. The south pole points inwards. So from this diagram, as we can see, X and Y, they attract each other. Similarly, Y and Z, they attract each other. So they will be, X and Y will be different poles, same as Y and X, Y and Z. So from here, we also can see that X repels with Z. So X and Z will be having the same pole. Then we look at the direction of the arrow. Pointing outwards, it will be the north pole. So X will be north, same as Z will be north. Pointing inwards will be the south pole, so Y will be the S. Hence, the answer will be B, X north pole, Y south pole, and Z is the north pole. Question 39, given this diagram. The diagram shows a pivoted coil between the two poles of a magnet. The pivoted coil carries a constant current in the direction shown. When the coil is released, it rotates and eventually stops at an angle theta to its initial position. When viewed from X, in which direction does the coil rotate, and what is the value of theta? So here are the four options. Basically, you have to identify whether the direction is anti-clockwise or clockwise direction, and the angle is either 90 degrees or 180 degrees. Alright, so to answer this question, we need to know Fleming's left-hand rule. So this is Fleming's left-hand rule, where the index finger will point from north to south pole. The middle finger will point the direction of the current flow, while the thumb will point the direction of force. You have to make sure that these three fingers are perpendicular to each other. Alright, now let's position our left hand with this Fleming's left hand rule at the north pole here. So our index finger is pointing from north to south, followed by our middle finger is pointing the direction of the current, and your thumb should point downwards. So this will be the direction of the force. Next, we place our Fleming's left hand at the south pole end. Now, your index finger is pointing the direction of field from the north pole to the south pole. Then your middle finger is pointing at this direction, which indicates the flow of the current, and you will realize that your thumb is pointing outwards. Alright, so from here you can see that the left side or the left arm of the coil is going down, and the right arm of the coil is going up. So it will rotate in this direction, which is anti-clockwise direction. Next, to determine the angle theta, at this angle, this coil eventually stops, which means carbon brush is between the gaps of the split ring commutator, and no current flows through the coil. And coil does not experience magnetic force, hence the angle should be at 90 degrees. So the answer for this question is A. Direction is anti-clockwise while the theta is 90 degrees. And we come to the last question, question 40, given this diagram. When a magnet is moved quickly into a coil of wire, a deflection to the left is seen on an ammeter connected to the coil. The magnet is pulled slowly out of the same end of the coil. What happens to the direction and size of the deflection seen on the ammeter? So here are the four options. You need to determine the direction of the deflection, whether it is to the left or to the right, and the size of the deflection, whether it decreased or unchanged. Okay, so to answer this question, we need to relate it to the Lenz's law. According to Lenz's law, the induced electric current always flows in the direction opposite the motion or change that induces it. The greater the change, the more current is induced, which means more deflection, and vice versa. Alright, so since at first it moved quickly, the deflection is to the left. Alright, and now when you pull slowly, then the size of deflection will decrease. Because of this point, if we have less change, then less current is induced. So the deflection will be decreased. And we change the direction. At first we move in, now we move out. So the direction of deflection will be opposite. At first when we move in, it is to the left. So when we move out, it will be to the right. Hence the answer will be C. Direction of deflection to the left, and the size of deflection decreases. Alright, that's the end of the paper, and that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, see you in the next video. Have a great day ahead and all the best.